Good morning. My name is Kirk Johnson. I'm the SANT Director of the Smithsonian's National Museum of Natural History, and I'm coming to you live from the National Museum on the National Mall in Washington, D.C. It's my pleasure today to host an event with NOAA to talk about ocean science. And it's a great place to do that because the National Museum has been an ocean museum for many, many years. We have the SANT Ocean Hall, one of the world's largest collections of marine specimens, and numerous scientists who study the ocean in many different ways. One of our former board members was Dr. Jane Lubchenco, who was a former NOAA administrator. Today, we're going to have a really cool program. We'll start with a conversation between Symone Barkley, who's an educations and exhibition specialist for NOAA, and Dr. Derrick, who's the President's Science Advisor and the Director of the Office of Science and Technology Policy at the White House. After they've chatted for a while, we're going to go live to the NOAA ocean vessel called Oceanos Explorer, which is located off the coast of the southeast United States, maybe 70 miles offshore, and beam live information in from that ship to the museum. Following that, there'll be a high-level conversation between Dr. Rick Spinrad, who is the NOAA administrator, and Dr. Derrick, the chief science advisor to the President of the United States. So have a fantastic time watching this and enjoy.
Ocean is, well, it's pretty amazing. I mean, I came to understand much later in life just how cool the ocean was. Yeah. And you know all about it. And so I'm hoping to learn a lot from you today about the incredible work that goes on in all the different ways about the ocean. So I was wondering if you could just, tell me a little bit about, how you got into any of this and it's just, and what you love about it.
Yeah, so I also love the ocean, and I also think it's amazing and gorgeous. And so I didn't grow up near the ocean, though. I'm actually from Baltimore, and there's not really an ocean that's close by, but there are local waterways, the Chesapeake Bay, of course. And so when I started learning about the Chesapeake Bay and realized that I wanted to learn more about the ocean, I watched nature documentaries on TV, and then I decided to go into a student summer program at the National Aquarium, which is also based in Baltimore City. And during that program, I got to learn about all of the exhibits that were in the aquarium building, all of these species that were in those exhibits. And so that really intrigued me, right? Made me very curious, made me very curious about the ocean and about the habitats. So that's really how I realized, that's important to talk about science, that's important to communicate about, conservation while I was at that aquarium doing those work.
Well, it's interesting. So you grew up in Baltimore. I grew up in Brooklyn, New York. And I guess in theory, we had ocean around us. There was this Belt Parkway that went around Brooklyn. Yeah. And if you look to the left, there was ocean. But I gotta say, my experience with ocean was maybe going to Coney Island or Jones Beach. And so the ocean was like water off the coast. And I was probably familiar with the first 20 feet of the ocean and not any fish or other kind of life in the ocean. And so, I think that's probably true for so many Americans. They either grow up not near the ocean at all, or if they are near the ocean, it doesn't really mean so much to them. So why is the ocean so important?
Okay, so there are countless reasons why the ocean is important,
give
right?
Me a countless number.
Yeah, I'll give you a couple, right? So number one, every other breath that we take comes from the ocean.
Wait a second, wait. Yep. So if I go, ocean, not ocean, ocean, so that's it. Yeah. I mean, every other breath.
Every other breath is produced by marine photosynthesizers, so they produce oxygen in the water, like phytoplankton and different types of seaweed. So first of all, we should be thanking the ocean because it's literally giving us life.
And the other breath is from the trees and things?
Yeah, some from other things that are photosynthesizers, absolutely.
Cool.
Amazing. And then, of course, on top of that, you were talking about how, you necessarily didn't live super close to the ocean, same as me, but more than 40% of the global population lives within 100 kilometers of the ocean and of the coast, which is pretty interesting. A lot of us are living near the body of water.
Well, probably
right?
The ocean's pretty useful.
Yes, and the ocean is massive, right? Think about how much of this planet is water. Right. And so in addition, we also get a lot of our food and protein from the ocean, right? 10% of the world's population is dependent on fisheries and aquaculture for their livelihood. So I think we should thank the ocean for that as well. tons of reasons to thank the ocean. Of course, also, the oceans enable 80% of shipping. So that's really important for all of the things consumers are buying, all those goods, right, come from the ocean because they're being transported there. And then 80%, I think this is astounding, 80% of all life on this planet is found in oceans.
But 80% of all life.
Of life, yes.
So I guess, yeah, that always blows my mind to think
right?
about it. But of course, you know, when you think about land, life on Earth, it's just like this thin layer that we live on. And the ocean, you got like this whole column of water going up and down.
Exactly.
So I suppose there's a lot more total livable space in the ocean.
Right. Which I think is very interesting, right? And we're going to actually talk about like the water column and see what's deeper in the ocean, right? Because there's tons and tons of species that are there. So I love it. And then, of course, I cannot miss this really great fact is that blue carbon sinks like your mangrove forests, your seagrass beds, and other vegetated ocean habitats can sequester up to 5 times as much carbon as tropical forests. So that's really great. We're talking about climate and we're talking about, you know, climate change and the ways that we should be working to address it. The ocean is definitely one of the places that are doing that.
Shipping, and we got food from the ocean, and we got it as a carbon sink. And so presumably it's pretty important we take care of the ocean,
right?
Because it's a resource for all this stuff, I mean, like so much of life on Earth. So it's important that people get interested in the ocean so that they actually know about it. And so how do we do that? You got interested in the ocean, but tell me more about how we get people interested in the ocean.
Yeah, so, you know, first I would say, like me, right, I got interested through informal education, right, through like watching programs on television or through, you know, my time spent at the aquarium or, you know, in museums like this one. So I would definitely say that spending time in informal learning institutions is very critical to really helping to build a personal connection. And then, of course, I also would like to, you know, talk about how when you are, you know, becoming interested in something, you normally become interested because you met someone who does the thing that you're interested in, right? When you like see a firefighter and you're like, oh yeah, I want to be a firefighter because that looks really cool. So you want to make sure that people are building personal connections, relationships with someone who looks like them to show them what kind of opportunities there are.
So that could be me doing it.
Exactly. So you can see themselves, literally, I can see myself in that position. And so I'm going to share a story. Can I share a story with you?
Yeah, I want to hear.
Okay, so when I was a Knaus Fellow, and I
actually... Knaus Fellow is what? What's a Knaus Fellow?
It's a Marine Policy Fellowship, and I was Knaus Fellow in 2016.
Oh, cool.
And during that time, I actually participated in a program called The Expert is In, and it was held here at this museum in the Ocean Hall.
And you were the expert?
I was the expert. That's what they calls me, but...
All right, no. If you're a Knaus Fellow, it sounds like you're an expert.
So I was in the Ocean Hall, and my session was about sharks, because I studied sharks when I was in graduate school. I studied sand tiger and sandbar sharks. So I'm talking, you know, to a really large group, and this is a group of mostly all Black students and chaperones, okay? And so there's a picture of me, like on this cart that I had, there's a picture of me, and it says like my name, and it says, you know, the expert is in, Symone's gonna talk about sharks, and there is a picture of me like holding a sand tiger, like the rope that we had it attached to on our boat, right? I've talked to this group for 10 minutes, just chatting, telling them about all the things, and finally, a little boy in the group looks at me, and he like stops me in the middle of what I'm saying, and it's like, is that you? Is that you on that picture? And I'm like, yeah, I've been talking to y'all for 10 minutes. Like, I thought you would have caught on that it's me, right? And they're like, no, that's really you? And I'm like, yes. And he's like, wait, how do I get your job? How do I do that? Because I didn't know that that was something that I could do. And so right there, it really clicked to me, you know, that it's really important that we share our stories. It's really important that we talk about, you know, the experiences that we have, and that we show people, you know, no matter where they're from, you know, that you can do this too, that this is something that is achievable for you, that there are other options out there besides like your same, you know, careers that you typically hear about. You know, this field is so massive, and I would love for there to be more people here. And then, of course, you know, when I worked at okay, this is another fun anecdote, right? This is, my life has like a lot of full circle kind of stories. So I talked to you about how I was a volunteer at the National Aquarium when I was in high school.
Yeah.
I actually worked at National Aquarium for a little bit over 4 years and managed their education programs after my Canals Fellowship. Okay, so while there, I also did lots of career days, went to lots of schools throughout the Baltimore City and talked about my work as a marine scientist. And while doing that, I remember there was I will never forget this, there was a young lady, her name was Lavender, and I was talking about my work as a marine scientist. She came up after me and she was like, can I just let you know that I really appreciate you being here because there are not a lot of Black marine scientists, and I feel really happy to have met you and to see you today. Lavender.
Yeah.
So it really just, again, reiterated what I learned 3 years prior, right, when I was in Ocean Hall, that it's really important for me to continue to share my stories and for everyone to have a space where they feel like they can belong.
Well, I mean, I think whatever you do in your classroom, meeting real scientists, real people, and realizing people. I mean, look, for me, growing up in Brooklyn, I grew up in a neighborhood, a little bit before your time, maybe, but I grew up in a neighborhood with no scientists, nobody with PhDs, wouldn't know any of it. And New York City had a math science high school, and I got to go to it, a public free high school. And if I hadn't met those people, I would have certainly never imagined myself doing anything like this.
Yeah.
So I don't think either of us can overemphasize how important it is. So I'm curious, are there organizations that are taking up the responsibility of doing this today?
Yeah, so I'm very happy that you asked that because contrary to popular belief, there actually are a number of organizations that are really starting to build that sense of belonging in the oceans and marine science field. And a few of them that I would like to call out are Black in Marine Science, Black Women in Ecology, Evolution, and Marine Science, Minorities in Aquaculture, Minorities in Aquarium and Zoo Sciences, Minorities in Shark Sciences.
Wait, Minorities in Shark Sciences?
I know.
Did you have something to do with that?
No, so I didn't. I'm not part of the founding members of that group, but I know them very well. Hi, Jada. Hi, Carly. So yeah, I know many of the people who have started these groups, and these groups really came out of, wanting to build that sense of belonging, build a sense of community that we didn't necessarily have, before. And so the list goes on. To ensure that we get everyone not only interested in marine science, but also appreciative and protective of the ocean, it's really important that we prioritize the voices, experiences, and the research of people from groups across the world, right? From Black people, from Indigenous peoples, and people of color, because we want to make sure that they can then reach back to their communities and build that connection. And we know that the climate crisis disproportionately impacts communities of color.
Definitely.
Yeah, and lower socioeconomic status. And so that's reflected as there being less green space in those communities. Even like in my community, in my neighborhood where I live in Baltimore, we don't have a ton of trees outside of my house, right? Increased air pollution and food apartheid in our neighborhoods. There also isn't a lot of there aren't a lot of grocery stores near me. So all of these things are, what we talk about when we say environmental justice, when we talk about how that's so important, So it's very important to me, and I think it's important for all of us to make sure that we are prioritizing these voices and that we are acknowledging the contributions that people of color have had to sustainability by like reusing, different materials, right, and not just throwing them out. So plastic bags, for example, people reuse them all the time, and so we want to make sure that they are also being acknowledged for the work that they're doing to contribute to protecting our Earth.
Well, look, in my job at the Office of Science and Technology Policy and the White House, I mean, I agree with you. This is so important that everybody get to participate in science and get the benefits of science too. And it's not just like a nice to have kind of thing. No. I think it's essential to science because if you think about what is science, but people coming along and making observations that's nobody had made before. Yeah, that's what a discovery is, and you're going to do it if you see things differently because you bring a different lens or a different perspective or a different set of interests or something. And so, if we don't have everybody involved, we're cutting ourselves off from all these sources of inspiration. And then I also think, as a country, if we have only a small fraction of our country really engaged in science, how are we going to compete in the 21st century?
Yeah.
I mean, we're going to need everybody part of this whole thing. And so, there's of course the reason that it's fair and it's right to have everybody involved, but it's also self-interest as a country to make sure that everybody has the chance to be involved if they want to.
Yeah.
And I think the emphasis you place on what is that on-ramp into science, it's different for different people. We got to make sure there are enough opportunities to come on in to maybe like jump in the ocean and splash around, I suppose.
Yeah,
So,
absolutely. I think that we should get ready to talk a little bit about how we're going to transition into doing our live interaction.
so we're going down to the to the bottom of the sea.
Ready for that. Yeah.
All right.
I want to highlight one particularly inspirational deep sea explorer, Dr. Dawn Wright, who is the chief scientist at the Environmental Systems Research Institute, ESRI. She was the first Black woman to explore the deep ocean in a human-occupied submersible in 1991. And back then, the deep sea exploration was in many ways, right, kind of like a solo adventure. It was kind of closed off from the rest of the world, right, where you were disconnected from everything and everyone else. But technology development has allowed for new ways to explore the ocean and for everyone to be able to participate. For example, by streaming large amounts of data like video to share in real time.
Yeah, that is so cool. And we're going to do that today.
Yes, that's what we're about to do right now.
That is so cool. And it turns out that what we're going to see is a live feed that's going to keep going. It goes, it's around all the time. Even when you and I aren't here, it keeps going.
Yes, it actually does, right? So folks can check it out even after we're done this live interaction. They'll be able to see it.
They can do that on their cell phone when they're walking around.
Yep. Yes, when you're doing anything, you can be able to see
go down to the bottom of the ocean. Well, that is so cool.
I know. I absolutely agree. So NOAA Ocean Exploration is celebrating 20 years of ocean exploration in 2021 and is the only federal program exploring the deep ocean and our basic understanding of deep waters and the seafloor. As the only federal program dedicated to ocean exploration, NOAA Ocean Exploration is leading national efforts to explore our ocean and making ocean exploration more accessible by filling gaps, in the basic understandings of the U.S. deep ocean and the seafloor. Using the latest tools and technology, NOAA explores previously unknown areas of our deep ocean. So these are places that we didn't know anything about.
So we're going someplace that's unknown.
Yep, unknown, right? Making discoveries of scientific, economic, and cultural value to strengthen the economy, health, and security of our nation. NOAA Ocean Exploration supports exploration in many different ways through grants and partnerships, technology development, and through its dedicated vessel, NOAA Ship Okeanos Explorer. The Okeanos Explorer is the only federal vessel solely dedicated to exploring our largely unknown ocean for the purpose of discovery and the advancement of knowledge about the deep ocean. Such exploration supports key NOAA national and international goals to better understand and manage the ocean and its resources. Before we connect to the ship, we are going to share a video on why and how we explore, made by NOAA's partners.
So let's go look at the video.
Most people don't think about the bottom of the ocean. When you look at maps, the ocean is portrayed as flat blue with very few features. However, this couldn't be further from what the ocean looks like. Picture huge mountains, exotic hydrothermal vent forests, and features that seem otherworldly, supporting diverse life that is just as alien. The ocean covers 70% of the Earth's surface, yet there are still so many things we do not know about its topography or ecosystem. There is more life in the ocean than anywhere else on Earth. The water column is the largest yet least explored habitat and is home to animals that captivate the imagination. As far down as 3.5 miles, there are species of coral over 4,000 years old. Mineral-rich, superheated water create towering chimneys that can hold as much life per square meter as a tropical rainforest. It is believed that hydrothermal vents like these may be where life on Earth first began. There are predicted to be millions of unknown species whose contribution to ocean and human health is still unknown. The deep ocean has already given us compounds to treat diseases and develop diagnostic tools. 3/4 of the Earth's volcanic activity occurs in the deep. Data gathered from deep-sea exploration can help predict earthquakes and tsunamis, potentially saving thousands of lives. High-resolution maps reveal new features and guide scientists to unexplored areas where further study can take place. A map of our seafloor will be an invaluable tool in protecting our ocean. Thanks to game-changing technological advancements like submersible vehicles, autonomous underwater robots, sensors, and cameras, we can now look into the ocean like never before. Gaining visuals and samples from our deep ocean is critical to unlocking a better understanding of the world's ocean. This effort can only be achieved through cooperation and collaboration. The ocean plays an important role in everyone's daily lives, no matter where they are on the planet. Ocean exploration is about making discoveries that help us better understand the world we live in. Exploring our ocean is key to managing and protecting it. Vessels like NOAA's Ship Okeanos Explorer, Ocean Exploration Trust Nautilus, and Schmidt Ocean Institute's Falcor are helping to explore our ocean through open data sharing, live streaming, and robust public engagement programs, are providing opportunities for everyone to get involved and make a contribution. Together with other science collaborators, we foster interest in what lies beneath the ocean surface, exploring our ocean and better understanding what lies beneath.
All right, we're back.
I know.
I'm really excited.
Me too.
So the Oceanis is off the coast of sort of southeast, sort of south central Florida, I think. It's like 250 miles or something like that out to sea. And it's on an expedition that has a name. Apparently they name expeditions, which is cool, called Windows to the Deep 2021 Southeast U.S. ROV and Mapping. So that's what I was told, at least. And it set sail on October 26th, a little more than a week ago, from Charleston, South Carolina, to get out there. And they are going to this big expanse called the Blake Plateau. So it's one of these big plateaus that goes farther out into the sea than most of the coast. You've got this just little narrow bit, but this one goes out like 250 feet before it falls off at this Blake Spur wall, this bit that sticks out. And here's what I learned so far. And I didn't know this till we started prepping for this, but what I learned is that they are out there, NOAA's out there mapping the seafloor first by sound waves. It's using acoustic stuff, bouncing sound off the bottom, seeing how the sound reflects back, and using computers to reconstruct what the shape of the floor of the sea must be to produce the reflection. And it's basically like bat echolocation or dolphin echolocation, but I don't think they use any bats or dolphins in the process. No, it's all done by computers now. And then if something, once they got a basic map, they send out this ROV, the remotely operated vehicle. So no people. No people. And though this remotely operated vehicle is so connected, everybody's used to now with the pandemic being connected. You get on your favorite video conferencing thing, Zoom or whatever. And so apparently this ROV at the bottom of the ocean also knows how to log into Zoom or whatever it's using. I don't know what it's actually using there. And it's video conferencing up, or maybe actually I think there's like a cable that goes down. And then we're all getting to participate in the video conference with what's going down there. So, what blows my mind about that is just how many people can effectively be on board the ship without being on board. Like, we're going down to the bottom of the ocean, and like we're here in Washington, D.C. And 10,000 people could go down to the bottom of the ocean, which what you were saying before must open this up to so many people.
Absolutely.
It's pretty remarkable. So if you want to link to it, I think in the YouTube description accompanying this, there is the actual link. I think we're going to be seeing it here, but anytime you want to, and you should save it like on your phone so you can go there and look at it. So anyway, it's time to go to the ship. Are we ready to go to the ship? It's going to be, I don't know, a couple minutes or so they'll be ready for us.
Yeah, I think so. I'm really excited to see.
So what's going to happen?
Okay, so what we're going to do is we're going to talk to a few other folks who are on the ship. We're going to ask them about their roles, their job, how they got into it, kind of like what you and I just did a little bit,
good.
you know, a little bit of background. And hopefully while we're doing that, we'll get to see some of the live footage of what they're looking at on the expedition. I'm looking because it looks like
They've appeared.
Yeah.
And we're going to be able to ask them what's going on?
Yeah, we're going to be able to talk to them and ask them, and they're going to give us answers because you and I, we don't know. We're over here trying to figure it out.
All right. Well, there you are. Hello. Hello, Okeanos Explorers there. Great to get to see you. Thank you. Do we have audio between us?
Can you hear us?
Now we can. Fantastic. Could Symone and I ask you to just introduce yourselves to everybody?
Good afternoon, everyone. I'm Commander Manning. I'm the commanding officer of the Okeanos Explorer.
Hey everybody, my name is Derrick Sowers. I am the mapping lead on this expedition for NOAA Ocean Exploration.
And I am Alan Collins with NOAA Fisheries and the Smithsonian National Museum of Natural History, and I am co-biological lead on this expedition.
Wow.
Fantastic. And at some point you're going to start showing us the feed from this ROV, I guess.
That is correct.
Cool.
Yeah, and so since we are going to be doing this live, right, we don't know what we're going to see. We aren't sure what we're going to see. There's no way we can kind of predict what's going to happen. So,
surprise to us.
Exactly. It'll be a surprise to us and likely be a surprise to them too, which is going to be really exciting. So as we are talking with them and kind of, you know, having a little bit of conversation, if we might interrupt and say, hey, can we talk about what we just saw on camera right there? We just want to make sure that our audience is aware that we'll get back to the questions after we are able to talk a little bit more about what we're seeing on the feed.
Yeah, because if something really cool goes by, we don't want to miss getting a chance to ask them about it.
Right, exactly. Okay, so we're going to start. Commander Manning, would it be all right if we start talking with you first?
Absolutely.
Okay, perfect. So can you talk to us a little bit? You told us, you know, about your role, but can you tell us a little bit more about your responsibilities on the ship?
Oh, I sure can. So as the commanding officer, I'm responsible for the safety of the ship and the personnel on board. So we drive the ships. We have a cadre of NOAA Corps officers. It's a commissioned personnel system that operates the ship and navigates it safely to all of the research sites that the scientists want to go. There's a lot of planning that goes into that. We work very closely with Office of Exploration to map out those sites, and then we take them there and we get them back home safe.
Wow. And so can you talk a little bit about how you are able to get a 9,000-pound ROV into the water? Because that sounds a bit insane to me.
9,000 pounds?
Yeah, exactly.
Wow.
Well, I think of it as a very specially choreographed ballet between the officers on the bridge, the deck officers, the scientists, the engineers, and the pilots. And we all work together. So we've got people on deck, and we've got a pilot, and then we've got people that are driving the ship. Mm-hmm. And in conjunction with all of those people, we lift that 9,000-pound ROV off the deck with a crane, and we put it in the water as safely as possible. It's a very expensive asset, and so we work very hard to have procedures in place to make sure that no matter the weather, we get that ROV in there and out of the water safely.
So does the ship stay in place while the ROV is out exploring? Are you anchored? Can you tell us a little bit about if you're moving?
Sure. Our ship is a dynamic position ship. So we actually have computers on board that control our thrusters, and we have a bow thruster. We have 2 stern thrusters, and we have 2 stern props. And this computer operates all of those in conjunction with the position that we tell it to stay in. So we don't have to anchor. The places that we go are actually way too deep for us to anchor. We actually have a computer that holds the ship in position geographically over the water.
Okay, that is really cool because
very cool.
I mean, it makes sense that they're too deep to anchor, but to hear it out loud is pretty astonishing. Okay.
Dynamic anchor. Wow.
Right. Amazing. So acknowledging, of course, how curious you are about science, can you talk a little bit about the notable technological advances that you've seen during your career, since you've been in this career for so long?
Yeah, I've been with NOAA for about 20 years now, and I can speak specifically to some of the navigational advances that we've seen over the years. When I first came in to the NOAA Corps and first learned to be a ship driver, we've seen a lot of advances in terms of, like I just spoke before, the dynamic positioning system, as well as how we do collision assessment at sea. So we have to actually look at traffic, other traffic around us, shipping containers, sailboats, everything like that. We have to be able to see those and know if there's a risk of collision. So we have radars that help us with that. And we have automatic positioning systems. We have GPS. We have all kinds of great advances that tell us where we are in the space, in the ocean, because unlike on land, we don't have street signs and we don't have street markers to help us tell us where we're at. So we have to really understand how to get our position out at sea.
Wow. Now you're the commander, so you are in charge. And as you put it, you're responsible for the safety of the whole crew and presumably for getting this vessel back and the 9,000 pound, ROV and all that. But I heard from folks that you like looking at the live feed from the ROV. And even though you are not personally responsible for the science mission, you really are excited about this. So I was wondering if I could just ask you about what excites you about this. It might be, you say you're a ship driver, but you're driving a really pretty amazing ship. And it sounds like you really love that mission.
Right. Well, I actually have a background in biology, too. So, again, you were talking about all kinds of the different careers that you can go into with a background in biology. And certainly being a Corps officer is one of them that is very much a non-traditional route rather than academia. So I am absolutely fascinated with the biota in the seafloor just as much as the scientists are. And we have incredible scientists that come out. And I don't know if you've ever listened to one of those live feeds, but they do talk to all of the discoveries that they see under the ocean. And I learn something new every time they go down there. And I do sort of get sucked into the live feeds, just like people on land do. So we get to see what the ROV is seeing as well. And it's fascinating stuff.
Wow. Now, you've done this for about 20 years. So first, let me say, congratulations on 20 years of service in the NOAA Corps. It's a real gift to the whole country that you do this and to the world, because what you make possible with this ship. I'd love to know, what have you enjoyed most about what you've gotten to do? And I'm kind of curious, what might you do next?
Wow, there's a lot I enjoy about this job. I could speak to all kinds of things, the travel, going to different, international port calls. But for me, it's just being a part of the bigger whole or the mission of NOAA. And I'm always attracted to the basic research. I started out at the National Institutes of Health, which is all about basic research. And I am a big proponent of it, and I love the mission of Office of Exploration because they are about basic research, which is, as you know, in the federal government, that's always very difficult to, pursue. And for me, I think that some of our greatest discoveries come from when we're not looking for something, and we suddenly find it. So for me, it's kind of a dream come true to be a part of this mission. And I think that's what I really enjoy the most, that I, in my small way, can help out.
Wow. And next steps? do you have things you might do after you stop commanding a vessel?
Yeah. So after I get off the ship, I do go to a different assignment. I'll stay in the operations world for a bit, and then after that, I'll probably go back to school.
Oh, wow.
Wow.
Fabulous. Biology?
Yeah, I'm thinking of either marine management or marine policy.
Wow.
Well, congratulations and good luck with that. Wow. That's
Thank you very much.
Wow. Oh, thank you, Commander Manning. It's really great to get to talk to you. And maybe if it's okay, we could turn to Dr. Derrick Sowers. So, Derrick, if I can call you Derrick, if that's all right, and you should call me Eric. I only go by Eric. So, tell us what you do on the ship. What's your role? What's your responsibilities?
Well, the first thing we do when we explore is we need a good base map, an accurate map of what we're actually exploring. And that's falling into my realm of mapping. So on the ship that we're on here, we have the state-of-the-art scientific sonars that can map the shape of the seafloor, give us insights into the subseafloor geology that we're over, and as well as map concentrations of life in the water column. So we use all these sonars to really get that first exploratory picture of the area we're in. And then we take those maps and we find features of interest, and we further plan out a very safe and exciting ROV dive, and that's what we've been doing this cruise, is using those maps to inform where we put down the vehicle and really get a close look and see what's down there and share it with as broad an audience as we can.
So we're going to this place, the Blake Plateau, and like, why is that so special? Why do you have us going there? I mean, we're very excited about it, but tell us why you picked this destination for us and maybe for NOAA and everybody else too.
Sure, yeah. So first of all, where it is, the Blake Plateau is, just a reminder, the audience is off the southeast United States, so off a very populated coastline. And until recently, we didn't even have a basic high-resolution map of what was out here. For hundreds of square miles, this is U.S. territory under the jurisdiction of the U.S., and we just didn't even have a good map until recent years. So it's been known for some time that there was important deep-sea coral ecosystem here. But we've just recently had the funding, the ship time, the expertise to go and create a base map of this area. And what makes it so unique is what we have found here and been able to document and map is one of the most extensive cold water coral mound ecosystems in the world discovered thus far. We're talking about an area about 3 times the size of Yellowstone National Park, which is nearly continuous coral mound features, kind of as far as you can see. Just a huge area, and what makes these corals really amazing is they form over thousands of years. Some of the individual corals can be up to 700 years old. And what happens is the coral skeletons will die, and then a new generation will grow on top of them, and over thousands of years you get these mound formations. And we just have thousands and thousands of square miles of these. So if you could drain the ocean and look, you would see this amazing seascape that we just can't see. But we can see it with sound, and that's how we use the sonars on the ship. And this provides a lot of habitat for a lot of different marine organisms. So it's really important, really fragile, really slow-growing habitat. And that's something that we see throughout this region that we're exploring now.
Wow.
Yeah, so I know we both jumped when he's like, oh, it's 3 times as big as Yellowstone. Like, what? That's insane. Okay, also, you talked a little bit about, how the coral provides habitat, but can we maybe share about how mapping is used to share other information? Like, what kinds of decisions or what kinds of real-world applications does mapping provide?
Sure, yeah. So we strive to provide this information quickly, and it's all public information. And most importantly, we want it to be actionable information for NOAA and for other management agencies to make good decisions. So we're knowing what resources are out here, and we're making good management decisions. We're doing good conservation science. So in this case, the information has been provided directly to the South Atlantic Fisheries Management Council. They have sort of the management authority to choose how to protect that habitat. And they've set up habitat areas of particular concerns to protect these vulnerable coral ecosystems from anything that would kind of damage them directly, sort of bottom impact disturbance. So that's how that information is being used in a very practical sense. And in recent years, we've actually been able to find many of these coral mounds that are outside of the current protection area, so they're discussing now what to do with that information.
Wow. Okay, so it definitely impacts everybody, right? Like even me and you, it doesn't just impact those animals that are living down there. Can you tell us a little bit about what is your most exciting part of the job?
I think for me, it's, well, imagine your job is to go places that no one's ever been, such as, say you were going to Yosemite National Park for the first time, and you were the first people that could get there, could make a good map of the area, share it with everyone else, and really see what's there. That's kind of what we get to do as part of our jobs, just underwater. So I feel really lucky to be in that role. And actually, there's more of America underwater than there is in all 50 states combined. So we have about 53% of America's ocean is not yet even mapped, let alone having a look with something like the ROV.
53% of our ocean isn't mapped?
Of America.
Of just the part that's in America's jurisdiction, yeah, and far more than that globally in the international high seas. So there's a huge amount to explore. That's another important thing for our audience is this is a really amazing field to be in because there's so much opportunity. Many times when we dive, we'll find new species. We're using state-of-the-art technologies. We need people with all different kinds of expertise, both technical. You can see that this is a team effort out here, so there's an important role for everyone to make it work.
Yeah, I'm glad you said that because I do think it's really important, right, for us to be making sure that our audience knows that there are opportunities for you to come into this field. This field is so vast, right? And, we have already heard about all the different jobs and roles that someone can have in doing this type of work. So there's so much more for you. You could discover a new species, right?
You think about the surface land here and how, I don't know, in the past people would go out and be explorers and learn and find about new parts of land, but not so much of the surface of the earth that's unknown to us anymore. But you're saying that the majority of the discoveries are still to be made with regard to the ocean, with regard to the habitats and the things that live there.
Yep.
So it's amazing. It's like we landed on a new planet. It's just our planet, and it's all out there. That's pretty fantastic. So when you say you could find new species, how often do you find a new species? And do you get to name it?
Every field season,
if you discover it, do you get your
couple
name
dives
on it?
every expedition. So they're not named after most of us that go out to sea, but it's pretty common that either it might be new, or at least the scientists that we can engage with don't know what it is yet. So that it starts that scientific process of we think we found something new, we need to study it more. So we're getting that first look, and then we drive science in many new directions.
So you were talking about these coral mounds, three Yellowstones worth of coral mounds or something, and that it was a habitat for species. So what kind of stuff lives in those coral mounds?
Well, we see all sorts of other types of corals will grow right on. Deep sea sponges are prolific throughout this area. We have a lot of crustaceans that live in there. I would defer to my biological expert over here on the exact species. That's Dr. Collins' specialty here. So maybe we can transition over to him. He can answer your question in a little more detail.
Yeah, perfect. Thank you so much, Derrick. We really appreciate it. That was amazing. We were both shocked listening to some of the things you were sharing with us. Alan, can you tell us a little bit more about, what kinds of things are living in those coral communities, and then we'll get into some more conversation for sure.
Sure. So inside those deep water coral communities, there are lots of fish, tons of arthropods, pretty much almost every phylum you can name. So it's incredibly diverse. There's lots of nooks and crannies, and there are just every different kind of organism that you can imagine is living in there, animal-wise. Not so many photosynthesizers at that depth when there's no light. And then one of the things I'm really interested in is what we're showing here, which is the water column that is above the benthic habitats, including the cold water coral bioherms. And as you had mentioned at the beginning of the program, this is the largest inhabitable space on the planet. 95% of the habitable space on the planet is taken up by the water column, and it is home to literally quadrillions of organisms that make their home out there, and their biological processes are so important for pretty much the entire planet.
Okay, so can you talk to us a little bit about what makes an organism? You can give some examples, whatever organisms you want to talk about. But can you tell us what makes them, able to survive in these deep water habitats? Because we know, like, when Eric and I were talking earlier, we were like, we can't go down there, like we wouldn't be able to make it, right?
Yeah.
So can you tell us a little bit about how these animals are able to survive, or these species are able to survive in this environment?
Sure. I'd be happy to, because they have to face so many different challenges. When we send our cameras down there, we always send them with lights so that we can see. And one of the things that gives us is kind of this a false impression of what it's like, because once you get below 1,000 meters from the surface, there's no light at all coming down from the surface, and so it is dark. There's high pressure, and it's a huge space, so there's not very much around. It's very sparsely populated. So a lot of the adaptations that different deep-sea midwater organisms have are related to those problems. So we see the development in multiple different lineages, fishes, crustaceans known as amphipods, of these incredible eyes, also in cephalopods. So and enhanced abilities to perceive very, very small amounts of light in the environment. And then there are all sorts of ways that these organisms try to find each other. So jellies, which is one of the things that I study, they take two basic modes of trying to find their food. There are some that hold their tentacles out in front of them, and then they just cruise through the water, and when those tentacles meet a prey item, they sting them and then are able to eat them. And then there's a whole other set of jellies that basically deploy these long tentacles of nets, and so they're basically sitting and waiting for their prey to stumble along into their nets, and then that's how they find their food. There are, as I said, there's no light below 1,000 meters, and so a lot of these organisms are able to create light, and so there are a lot of adaptations around that as well. So again, with the jellies and other organisms, many times if they are feeding on bioluminescent prey, you can imagine that if you don't want to be seen and you put a lot of bioluminescent prey in your stomach, that you're then going to be this, big light bulb for a bigger fish that's going to come along.
Yeah, I was imagining.
So we see over and over again the development of these dark red pigments to the stomach, and that basically holds the light in and then prevents these organisms from being seen. Okay,
that was very cool, right?
Yeah.
That the stomach, right, is these dark red
pigments, so that
right, basically to hide the light from the animals, the organisms that they're consuming. That's amazing. This is utterly amazing. If you want to speak to any of the things that we're seeing right now, you're absolutely welcome to speak to any of those.
Sure. We're seeing a siphonophore there. That's one of the organisms that will deploy. It's a colonial organism that deploys a big net, and it actually has some of them have little side tentacles that act as lures. Some that are bioluminescent lures or physical mimics, and to attract prey. Yeah, exactly.
Wow.
And there we see a nice little shrimp, and it's got its bent antennae there, and those are really, they use that to sense the movement around them in the water, which allows them to detect either prey or predators.
What's that thing? That's pretty cool.
This is pretty cool. This is actually a sea cucumber, so it's a relative of starfish and crinoids and sea urchins. And the sea cucumbers, there's a group of them that can actually get up in the water column and swim around and look a lot like a jelly.
Wow.
And we just saw a little jelly running away there. And here's squids, which of course are very popular with lots of people because they're smart, they have big eyes.
Yep.
That's a comb jelly, Bathothyroid, that we see quite often. That's not a true jellyfish. It's in a whole other phylum called the Ctenophora, and that's very abundant. And we've seen quite a lot on this expedition.
Wow.
Wow. So we were actually just showing you all some canned footage that the ship has collected previously. So those were not things that we were seeing live.
Right.
But
these were the home movies from the
yeah,
Oceanis.
yeah. That was lovely though. That was amazing.
It was gorgeous.
Yeah.
Wow.
Alan.
Can
Sorry.
I just ask
Yeah, you go ahead.
You bring up these jellies here.
You
and I have been told that like he and I have this background, like he trained in math and then went to biology, and I trained in math and went to biology.
Yes.
And you ended up studying amazing jellyfish, and you are a jellyfish expert. And you keep mentioning jellies. Can we draw you out to tell us about jellies?
Sure. I mean, they are my favorite organisms, so I'm happy to talk about them.
More than people.
I think,
more than people. No, I can understand that. Perhaps, yeah.
Although I should say, while we're on that topic, that one of the best parts of my job that allows me to study jellyfish is how many young scientists I've been able to mentor and work with, and we share all this curiosity about the jellies, and then we try to figure stuff out together, and that has turned out to be my absolute favorite part of my job. So it's not something I expected going in, but it's what I feel right now.
So it's both humans and jellies. Tell us about the jellies.
Yeah, the jellies. They're in the phylum Cnidaria, and they have these stinging capsules, like all organisms in this phylum. And these microscopic stinging capsules are used in a whole variety of ways. To deter predation, to help them when they're feeding. These are such useful little structures. A lot of organisms that feed on cnidarians have figured out how to steal them. So they put them through their digestive tract, and they wind up putting them in the backs of their bodies as their own little stingers that they've basically stolen from cnidarians.
Stolen stingers. All right. Wow.
Stolen stingers. Yeah. Yeah. And one of the other things that I continually find fascinating about jellies is how people often have a negative connotation with them. Either they're taking over the oceans, or people have experiences being stung or being afraid of being stung if they go into the ocean. And yet at the same time, when there are jellyfish exhibits in aquaria, people always flock to them and love them. The motion is this sort of controlled chaos. It's always flowing. It's like staring into a fire at night, and so it's just really mesmerizing. And so people love jellies, and then they're also sort of afraid of them. And I just like that dual nature.
Wow.
I know. This is amazing. I did not know that about other organisms being able to like kind of steal the stingers. Never heard about that, but that's very cool. So we are actually going to show some coral mounds video next. So that's what you're seeing right now. And then we'll show some footage from yesterday's dive. But Alan, while we still have you, I would like to say congratulations. I know that you've been in these expeditions for many years, but I understand that this is your first time out on the large research vessel. Can you talk to us a little bit about what it feels like to finally be out there?
It feels great, basically. For a long time, I've participated as a shoreside scientist, and so what the biological leads do, like myself and my co-lead, Stephanie Farrington, we're basically trying to narrate these dives, but at the same time, we're in constant communication with scientists who are back on shore via either a chat room, or they can call in, or sometimes I even get texts from people, basically with a little note about what we're seeing, because we don't always recognize, biology is so huge. There are 1 million or so species known, we expect there would be about 1 million species in the ocean, and we only know about 250,000 of those. So we're constantly other scientists. And so here, to finally get the opportunity to be the biological lead and be out on this ship, it's kind of a dream come true sort of situation.
Wow. Okay. So I know, it was a lot. We're laughing because it is just insane to think about, right? About, you know, oh, there's like 1 million species, but we only know 250,000. Like, that's insane. But it's so cool to also know, right, that you all are able to communicate with scientists that are back on shore, right, that are working with you to help you be able to identify some of them. So that's kind of using your collective brain power, which I think is amazing. And it talks about how this work, kind of like what Derrick had mentioned, that this work is a collaborative effort, right? You are it's really about building that community to do this together, right? And you can't do it alone.
Wow.
This is great work. Oh my gosh. So I'm trying to get a glimpse at what we're seeing right now. Is this from yesterday's dive? This is from yesterday's
I believe
dive.
so.
Yes.
Yeah, this was that deep
What are we
mound
seeing?
site that we do.
Yeah, so what we're seeing are boulders that have fallen off the side of this mound, and trying to see. Oh, there, we're focusing in. Resolution is not. Sorry.
Yeah, we should mention that all of the dives we're doing are on our website too, so you can go back and replay them and replay highlights of the neatest things we saw on each dive.
Now that we've zoomed in, I can see a lot better what we're looking at. So this was a dead stock for a deep sea coral, and then lots of different organisms are colonized on it, hydroids, and then we see a really nice hermit crab, which had climbed up from the bottom onto the stock, the dead stock.
So what's that hermit crab gonna eat? What's its diet down there?
Well, it's picking up lots of little stuff from around it, you know. So it will, pick off little bits of whatever it's walking over, and so it's sort of a detritus feeder, or just pick stuff off the bottom.
So we should mention that those particles that Alan was just describing, they call that marine snow. And so it's all the life that happens up in the sunlight zone, actually all that particles kind of rain down upon the deep sea. And a lot of the life down here that's the linkage with the sun-driven ecosystem above. And that's how they get their food. They're particle feeders. So a lot of the organisms have little things to catch those small particles and ingest them and get energy out of them. So all those deep sea corals that we were talking about earlier, those are, most people think of corals, they think of things in tropical areas with sunlight. These are a different type of coral. They don't need any sunlight. They just are totally sustaining themselves off particles that are coming down from above. And like Alan mentioned earlier, they're living in total darkness. So very different, unique ecosystem.
Well, I never knew that.
We just scratched the surface of the global distribution of deep sea corals. Since we haven't been able to map and explore most parts of the ocean, we don't really yet understand exactly the full extent of where these ecosystems are distributed throughout the world.
So you don't have to generate all the food down there because it's just raining down on you all the time. That's pretty amazing.
All connected.
Wow.
Yeah. The other thing that we see in this particular area we're exploring, the Blake Plateau, is most folks are aware of the Gulf Stream that comes through here, comes around Florida and up along the East Coast and then out towards Europe across the Atlantic. That has more volume of water that's moving than all of the freshwater rivers in the world combined. And that's full of some of this food source, and it's moving it at a high speed through these ecosystems, so it's just pumping food into these areas, and that's where we tend to see the densest corals on the seafloor.
Right there, we're looking at a precious coral, the Corallium or Hemicorallium. We're not sure of the genus. And that one has been you can see that it's been knocked over either by the currents or something like that. Then I just wanted to talk about the marine snow that's raining down. It's nutrients, but that's how carbon from the upper part of the ocean gets locked into the ocean floor, sequestered away, so that it's taken away. So it's a really important part of the carbon cycle on the planet.
So that's a long-term storage for that carbon, a carbon sink down there on the bottom of the ocean?
Yes, it is. Exactly.
And what happens if it was doing trawling and stirring up that stuff? Would that be bad?
I think there's some recent studies and literature on that try to estimate the amount of carbon that can be released by some of those activities. So it's definitely an important consideration on how we do what management actions we take in the ocean and how that affects our climate mitigation efforts, globally.
Yeah, it's funny. We actually had a question from we were able to ask our audience if they had any questions ahead of this, and we had a question from Aaron, and the question actually was, how does the deep ocean impact climate? And I think you all have just kind of hit on that a little bit. You've talked a little bit about how it does impact climate and how it does the deep ocean does sequester the carbon. So thank you for doing that. You annoyingly answered Aaron's question. So there you go, Aaron. You got your answer. But we are watching video footage from yesterday, and we had planned to show you some live footage. So can we just talk a little bit about why we're watching yesterday's footage and we aren't going live right now? Can you all share with us, what's happening?
We actually have an exciting update on that front. We literally just reached the seafloor live.
Well, just
right
now?
Woo!
Seafloor.
Oh.
Yes.
This has been incredibly difficult.
Yeah, I don't know if you can see behind us on the video screen. We've just touched down. We have some dark-colored boulders, some very rough seafloor terrain we just landed on.
This is live from the bottom of the ocean. Wow.
Sure is. So possibly, if they zoom in on that rock, we'll probably see, I would assume that a lot of that white stuff are small sponges that are encrusting on the rock. We encountered so many just beautiful sponge gardens yesterday, not too far from this locality.
So something to keep in mind here, the vehicles are down at about 9,000 feet, roughly. They're attached with a cable running back up to the ship, and that has fiber optics in it. And that's how we're getting this live video feed up to the ship, and then it's being beamed to satellite and back to shore, and that's how it's shared on the internet link. So very exciting. We call this telepresence. It's like being somewhere where you're not. So we get to take people with us to see when we're out here.
Wow.
I just wanted to add that this is an incredibly difficult technical dive that they're doing right now because of the currents in this area. It's taken this long to get to the bottom because the challenges of driving the ROV in high currents. So we have a lot of incredibly skilled pilots that work for the Global Foundation of Ocean Exploration, and they are highly trained and highly skilled and very talented engineers that operate this vehicle for us.
So they're sitting there now driving this vehicle up on the Oceanis, but they are sort of driving this thing and making decisions about where it's going and trying not to hit something. What is that?
We're just pointing to the front row here where the pilots are actually sitting.
They're right there.
Tuned in.
Hello, pilots.
Driving the vehicle.
Yeah.
Yep.
I don't want to distract them because I don't want them to hit the thing. But thank you,
They're
pilots.
concentrating.
Yeah, okay. I'm not going to distract them, but there's some swirly
A little bit more
there.
context about this dive. We are actually on the edge of something called the Blake Spur. That's where the continental shelf drops off into the deep ocean abyss. It's about a 2,000-meter wall, so it's greater than 6,500 feet. Very, very steep. That's more vertical relief than the Grand Canyon. So we're basically diving kind of, if you can picture it, kind of at the top of the submarine Grand Canyon right now. And the currents are kind of swirling around the top of that and making for that really challenging dive that the commander just described.
Okay.
And there's been very little exploration work out here. That I think we're the first deep submergence vehicles that have actually been able to dive on this this amazing feature. So it's really exciting to be out here today.
Wow.
I know. We're just engrossed in looking at it. And we aren't really seeing a ton of like a whole bunch of life moving around, but it's still so cool, right? And a lot of people, talk about how exploring the deep ocean is kind of like exploring another planet, like a lot of people make that comparison, and I get that same feeling, I kind of feel that same way right now.
Oh, wow.
Yeah, it's absolutely true. So what we see here are, as I said, lots of sponges encrusting on this rock. and the mobile fauna is probably largely either small, tucked away in the rocks, or even yesterday we didn't see very many fish. They have different habitats where they're more abundant.
So some of these guys look like they're a little blue, and maybe some other things look like a little yellowy or orangey or something. Are those different species of sponges, or what are they? They're pretty.
Almost certainly, those are different species. So the sponges will grow with not like a defined shape, but a characteristic shape that's sort of amorphous but around a type. And many of them have different pigments, and so they definitely will appear different colors. Yesterday we saw a pinkish red, purple sponge down at great depths, and that was really a shocker. It was pretty interesting.
Wow. And you can even see their different textures, right? Like you can tell that if you were to touch them, right, that they all wouldn't feel the same.
Yeah. Sponges are a group that we are still learning a lot about. So we know about 10,000 different species, and the unknown sponge diversity is estimated to be many times more than that. They are challenging to identify, so taxonomically they're a difficult group, and so they do have different textures, but they also have their skeletons are made up of these little tiny skeletal elements, tiny spicules, and they arrange them in different ways, and they have different shapes, and that's often how we tell them apart. So via video, it's very difficult to make a very fine, precise definition of or identification of a particular sponge.
But could you go grab one of those things and bring it back to the ship?
Yeah,
because I want to see these. And I work on DNA and genome, so if you want to tell these things apart, you could sequence the DNA too.
Yeah, we do make collections, and we're able to bring those back to the ship, and then Stephanie and we've been preparing them so that we can send them back to the Smithsonian so that they can be studied by specialists in the different groups. I think today it's a little too challenging to collect, although I'm not 100% sure about that. That's always sort of a conversation that's going on. And then one of the other exciting things that you mentioned about that's related to DNA is we've been taking water samples on these dives, this first expedition where we've been doing that regularly, and we're going to extract DNA from the water samples. So it turns out that organisms will shed skin or loose DNA out into the water, and then we can collect that water, extract the DNA, and then sequence it, and then get another signature that helps us characterize the organisms that are there, and also will help us get a really good handle on the amount we don't know, because we certainly will find lots of unknown sequences for which we cannot find a perfect reference match in our known library, and that'll tell us where we need to work harder in terms of understanding biodiversity.
Wow.
I know.
This is so crazy. How long are you going to be out there? How many more days you got?
We're going to be out here till
November 15th.
Yeah, 11 more days.
Oh, I'm going to log on and catch the feed from the Blake Plateau and points beyond.
Yeah, me too. This is amazing. I'm so glad we got to, first, I'm very happy that we got to talk to you all, and I'm glad that we were able to get some of the live footage up too. That was perfect timing. That was fantastic. Thank you to everyone who's joined us.
Well, thank you, and good luck on the rest of the expedition, and thanks for everything you're doing for everybody around the world. It's really cool. Have a good voyage.
Thank you. It's been great talking with you.
Our pleasure.
Bye-bye. Wow. That was cool.
That was so cool. I was really about to ask the same question. So I know that they can make collections. I was wondering, have they been doing that, or would they be doing it in the future? So I'm glad you asked it. That was perfect. Oh, wow. This is amazing.
Yeah. No, I'm just going to say, I think, because I'm a member of President Biden's cabinet, I might be the first cabinet officer to go 10,000 feet under the ocean.
Yes.
In any case, I'm going to claim that.
Yes,
So,
you should claim that.
Yeah, I'm going to claim that.
And it was also cool. We're really in the perfect location for them to do this, for us to have done this interaction, because they were saying that they're going to make collections and then they will bring them back to the Smithsonian.
And we could come meet their collection here.
We could.
Because we got to meet the director of the museum at the beginning.
Right.
I like
we'll
that.
be back.
Yeah.
Okay. Perfect.
I'm just sort of like
I know.
recovering from the excitement of the journey.
Me too, because that was outstanding. And I'm going to be watching that in the future. Okay. Ready?
So now,
Yup.
hello, Rick Spinrad. We are honored to be joined by NOAA's administrator and Undersecretary of Commerce for Oceans and Atmosphere. And it looks like he really is an undersecretary. Are you under the water there? No. Rick Spinrad is a distinguished scientist who is the administrator of NOAA. And thank you for joining us today. And frankly, thank you for letting us visit one of the vehicles and visit with the people in the NOAA Corps. So you were watching this thing too while Symone and I were doing it. What were your favorite parts about all this?
Oh, man. Well, first of all, Eric and Symone, thank you for letting me join you on this. It's a terrific opportunity. And Eric, I don't think we've ever had a President's Science Advisor on a dive before. So thank you for doing that. It's such a great experience. I also want to throw out some thanks to Captain Manning and the whole crew. And you know what you see there is really the pointy end of this big spear of technology and science and information. And when you see these images, the archived images, but even more exciting, right? The ability to be there in real time, some 3,700 meters down or so, it just kind of makes your head explode to think that there's that much that we don't know about basically our own backyard. So for me, every time, and I've seen hundreds and hundreds of hours of these kinds of videos, never twice the same thing. Doesn't matter where we go in the world. And so, I mean, to be honest, I think I've got the best job in government because I get to watch this stuff all the time. What a treat. What a treat.
Yeah, but I bet you have to do more than just watch the movies. I think you're responsible for, let's say, continuing to improve the technology. Commander Manning told us about how much change there had been in the last 20 years that's made this possible. What's NOAA got planned for how to accelerate this kind of ocean science and ocean technology in the years ahead?
Yeah, it's really exciting to see the change. I started my government career working for the Navy in ocean sciences. And I can tell you that some of the things you saw, even though we're talking about a 9,000-pound vehicle, we didn't have that capability in vehicles that were 4 or 5 times that size just 20 years ago. So a lot of things are technologies from other areas that we're taking advantage of: miniaturization, new battery technologies, information technology. But I think the fundamental change that we're seeing right now is the use of what we called uncrewed systems. And that remotely operated vehicle is that years ago, if you wanted to get anything close to what you just saw, you'd go down in a submarine. You'd only be able to stay for a certain amount of time because you only had certain amount of oxygen, and then you'd have to come up, and you don't know what you saw. You don't know if it was representative of the whole environment or just a quirky new thing. Now we call it being resident. You can actually stay down there for hours, days, if you want. And so what we're starting to do in technology is use this uncrewed or autonomous concept for everything from aircraft to underwater vehicles, even some really new cool concepts for making measurements at the surface of the ocean. So I love to rib my friends in the space exploration community because we always get fascinated with this stuff. Well, first of all, I can guarantee you on every dive, we're going to find a new species.
They don't find them in space that often. Not that many new species.
They don't. And the other thing that I love reminding them of is we do this. We work really well under pressure. I mean, the images you just saw were taken
under pressure. Right.
2.5 tons per square inch. Imagine that, 2.5 tons of pressure per square inch. We do it in the dark. The temperature down there was almost freezing. And here's the best part. We can't use radio frequency communication. So you have to use acoustic communications or something else. So we have a real challenge in exploring the oceans that our colleagues over on the space side don't understand. And we love making sure they know that.
Just saying, yeah.
Just saying.
So like one question that came up, and Symone, noted that we'd received it on the internet, I think on Twitter actually, from Aaron about climate change and how the deep sea ecosystems contribute. Maybe I can ask you the broader version of Aaron's question is, tell us about how climate change is affecting the oceans, what the oceans can do to help prevent climate change. I mean, it's such an important question when you realize what a big portion of the Earth the oceans make up. So tell us, because I mean, right now the climate change meeting is going on in Glasgow. I'm even going to go over this weekend to be there for a few days of that meeting. So I'm really curious what you and NOAA are doing and learning.
Yeah, the climate change issue is a critical one, and I'll be joining you there as well, Eric. I'll be over there on Saturday, I think. And part of the argument that I'm making for the government here, for the American people, is that the oceans are a critical component of the discussion on climate change. And you framed it really nicely in terms of the impact on the oceans and then how the oceans can also help address some of the challenges. So the impact, the way to think about it is that the oceans absorb about a third of the carbon emissions, carbon dioxide that goes into the atmosphere from fossil fuel burning. About a third of that goes into the ocean. And one of the consequences we know about that is that it can make the oceans slightly more acidic. In fact, the oceans are now about 30% more acidic than they were, say, 50 or 60 years ago. And we don't fully understand yet what the impact of that is on the ecosystem. The other thing the oceans do is they absorb the heat. They absorb 90% of the heat, the additional heat associated with climate change. To give you some sense of how much energy that is, it turns out that that's the same amount of energy as if we lit off 4 Hiroshima-sized nuclear bombs every second for the last...
Every second?
Every second for 25
That does not sound like a good idea.
That's a lot of energy. So the oceans absorb all of that, and it has consequences. And part of the challenge for us is just understanding where all that heat is going. And so we're developing systems to measure that. But now let me give you the other side of the coin, because I am the eternal optimist, and I really believe that the oceans can play a critical role. In fact, many people may have heard, if they heard nothing else about a lot of the discussion going on now, they've heard this discussion about keeping global warming to below 1.5 degrees centigrade. And it turns out that you do that by capturing the carbon, and the oceans can capture carbon through phytoplankton, through mangroves, through other things. And we estimate that the oceans can account for about 21% of the solution to keep the global temperature down at or below 1.5 degrees. And that's just what we call the blue carbon piece. Then there's all of the roles that the oceans can play in renewable energy, whether it's through offshore wind or tidal energy, all of that. And then, of course, the oceans are going to be critical for sustaining the biomass and the biodiversity. You've just seen that in the video you saw. How many different species did we see in just 5 minutes of video? So the oceans are both bear a lot of the brunt in climate change, but I also think they can be part of what we call the natural solutions to climate change.
So thank you so much, Dr. Spinrad. Earlier, I mentioned that climate change disproportionately impacts communities of color. And I mentioned how important it is to center the experiences of marine scientists and build connections with those communities that will be impacted. Can you tell us a little bit about how NOAA supports communities in addressing the climate crisis?
Yeah, thank you for that, Symone. And let me also personally thank you for your story that you shared with us at the start of this broadcast. It's such a wonderful example of how NOAA and our organization can reach out and make sure young people understand what the opportunities are. So part of what I'm alluding to is our role in the educational arena. We have a number of programs, educational partnership programs and science centers around the universities, the historically Black colleges and universities and minority serving institutions. And we're looking at how we can use these even more effectively. How can we give students under and unrepresented minorities the opportunity to experience the kind of things we've been seeing on the video here. The other thing we're doing, and I think this is critical, and it's a key component of the president's agenda, and that is reaching out and listening. We're really good in the government at talking. We also need to listen. And so what we are doing in NOAA is we're doing a series of what we call climate equity roundtables. And we're going to different parts of the country to hear from impacted communities and vulnerable communities. And they may be suffering inordinately from things like urban heat, consequence of climate change, or flooding, or droughts, or fire. And so in order to build the products and services that we at NOAA are responsible for, we're reaching to parts of the country and to communities that we've not reached to before, with the goal of being more equitable in the development and delivery of our products. And the last point there is, a lot of people think, okay, you listen, then you kind of shut the door and build a product and deliver it. No, what we're saying is we're going to co-develop, which means things like using what's called traditional ecological knowledge. When you talk to communities, they have great knowledge, especially some of the indigenous communities in places like Alaska. They've been living there for generations. They can contribute to how we develop climate products and services. So that's the outward-looking piece and also the inward-looking piece in terms of diversifying our workforce at NOAA as well.
Yeah, thank you so much for that. I'm going to change gears slightly. So today we image what is relatively a really small area of the seafloor. Can you talk about how this work fits into the larger picture?
Absolutely. I love the comment Derrick made in the broadcast a minute ago, because I was going to say the same thing. The way I phrase it is, most of the United States is underwater. And people think I'm being figurative when I say that. It is literal. More than half of our country's real estate is underwater because of our exclusive economic zone going offshore about 200 nautical miles. That's about 4 million square miles that we really need to understand. Imagine it's 200 years ago, 215 years ago, and you're talking to Lewis and Clark. They really don't know what they're going to see in terms of landforms, species. It was a core of discovery. That's where we are with respect to our ocean. So one of the really exciting things is we've been aboard the Okeanos Explorer. That ship just reached a milestone of having mapped 2 million square kilometers of ocean floor. That's an extraordinary amount, but it's still a drop in the bucket. So we in the United States have a major initiative for mapping the ocean floor and doing it aggressively. We're working with the private sector. One last point on that. Think about what we started with in this discussion, the use of an autonomous vehicle, right? So the really exciting thing right now is maybe we don't have to rely exclusively on ships that are tootling along at about 5 or 7 miles per hour, mapping the ocean floor. Maybe we could put out hundreds of these autonomous vehicles and get that mapped even quicker. So it's an important objective. We need to, if we're going to conserve, if we're going to protect the land that is part of our country, we need to know what it looks like. We need to know what's there, and we need to know how it's changing.
Wow.
Right.
So can I switch gears for a second with you, Rick?
Yeah.
We got a question on Twitter from the National Ocean Protection Coalition asking about why biodiversity is so important and how we can best protect areas with high biodiversity, like for example, this one. And I know that, you and I have even talked that this connects with a big goal that President Biden has set for the country of protecting 30% of the land and 30% of the ocean to be able to, in a natural state, to be able to serve as kind of a reservoir for replenishing the bounty of our nature. And 30% of the ocean and 30% of the land by the year 2030. So I think it's called 30 by 30 or so. And, it's important to make sure that we stem extinction crises. So we have areas that are preserved, safeguard water and food supplies, because if you do that, then the other areas that you're using become more sustainable because things can move in from it, and all sorts of these things. So I'm curious, if you're going to pick 30% of the ocean, at least say in our exclusive economic zone, what kind of information do you need to make those choices? Because presumably you're not going to pick you know, lots of little tiny bits. You're gonna choose wisely. And since you and all your colleagues at NOAA are responsible for collecting all this information, I wonder if you could share with us how you're going to guide that kind of decision making about ensuring we protect that much, but also the right things.
Yeah, that's a great question, Eric. And, you know, I think the best approach is to think about how we've done that on land historically. When you go back to the legacy of Teddy Roosevelt and others who said we need to build a national park system. Why is Yellowstone protected as a national park? In part, it's because of the biology, the very special species that live there. In part, it's because of the nature of the landforms, the incredible geysers and hydrothermal systems. And it's because of the uniqueness of these. And I'd say the same thing applies to that other portion of the United States and the world, for that matter. If people have captured anything from that video that we were so fortunate to see just a few minutes ago, they probably got the sense that, gee, the ocean bottom out there, in what for most people is probably just a boring part of the globe, is really actually pretty fascinating. And so if that part of the world looks like that, what other really interesting environments do we have? So part of the justification for the 30 by 30 conservation approach that you just described is making sure that we can sustain those highly productive, rich environments. If we don't know where they are, how are we going to do that? So you can't conserve something if you don't know where it is and what it's part of. So we feel strongly that we at NOAA have a full spectrum of responsibility. Part of it is exactly what you just saw. Get out there with an exploration vehicle, a dedicated exploration vehicle. This isn't just some pastime. We are doing this 24/7, 365 with the Okeanos Explorer, and intend to keep doing that and find those areas, which takes a lot of time and effort to do. And then the other part of it is that we have a responsibility in the government to establish some of these protected areas. We have the National Marine Sanctuary system within the US, and we have the National Estuarine Research Reserves. So we have a few mechanisms that we can build these special areas into. And you may have seen, it's not just the sort of physical and biological features. We just announced the establishment of a new sanctuary on the Wisconsin shore, and it's the Wisconsin Shipwreck Coast National Marine Sanctuary. So it's not just about the physical and biological resources, it's also about the cultural resources.
Wow. So Rick, I'm going to put you on the spot. We only have 2 minutes left, but what is your personal favorite spot in the ocean?
The bottom.
No. Well, the administrative, no, you've been to the oceans and sailed the seas. What do you like? What's your favorite spot? If you could pick one spot to be looking at, what would it be?
You know, so Eric, my background, my career is as a physical oceanographer, and what I really studied early in my career, when I was a solid scientist publishing papers, was to understand what we call radiative transfer, which is really a fancy way of saying how light penetrates the sea. And so my answer is going to be a little less ambiguous than what I first said. It's going to be wherever there's something of a unique nature associated with light. So for me, that means both the twilight zone, that deep part where you can't really tell where up is and down is. But the other thing is wherever there's bioluminescence. And just one last comment. Early in my career, I had the opportunity to do a dive in a manned submersible, as we call them, in the Gulf of Maine, where there are bioluminescent phytoplankton. And I convinced the pilot to set on the bottom of the Gulf of Maine, where it was really dark, and then to turn all the lights off on the submersible, to turn the props this way and spin them. And we got a fireworks display of phytoplankton. That, to me,
I love it. You are someone who follows the light. I love it. Symone, it is so cool to get to work with you here and do this together and go to sea with you.
Yeah, this is amazing. Thank you. And to our audience, please check out the resources that are linked in the YouTube page.
Goodbye, everybody, till we go to sea again.
Bye, everyone. Thank you for joining.